All right, next question up here. And the first thing we do, as always, is read that question sentence first. And so let me help you out when it comes to distance, rate, and time questions. When we read the sentence, what is the average speed for the entire trip? Remember that the formula must be consistent. If I'm going to be using my distance equals rate times time formula, and I'm trying to find the average speed for the whole trip, I need the distance for the whole trip and the time for the whole trip. You have to be consistent. And this goes the same if we're talking, let's say, hey, let's find the rate for the first part of the trip. Well, if we want the rate for the first part, we need the distance for the first part and the time for the first part. So again, consistency is key. Representation and consistency therein, that's important. So let's get to work here. We see that the car drives this many miles at this speed, then this many miles in this amount of time. There's no break. So what's the average speed for the whole trip? Well, here's how we're going to get this done. The first part here, boom, we have miles right there. And then for the second part, we see that we have miles right over here. So I can get the distance for the whole trip rather quickly because I have 84 miles on the front part and then 96 miles on the second part. So once I add these together, 4 plus 6, it's going to be 10, carry the 1. Then we have 1 plus 8, which is 9, plus another 9 is 18. So we have ourselves 180 miles. Boom, there we are. That's the whole trip right there. We're looking for rate, so I'll just plug in the R. And now to get the entire time, well, we're going to go ahead and find the time for the first part, find the time for the second part, and we're good. So the time for the second part's actually given to us as 2 hours already. The first part, we see 84 miles, 42 miles per hour. We can create a distance, rate, time formula specifically for the first part. 84 miles is the distance for the first part. 42 miles per hour is the rate for the first part. And we'll find the time for the first part. So now that we're here, we'll divide both sides by 42, here and there. And once we do that, cancels out on the right side, and we get 2 hours. Again, that's for the first part of the trip. So boom, we have that right there. 2 plus 2 equals 4. And we know now that we have 4 hours total. So there's the whole trip. Now we can divide and get this done. Divide by 4 on both sides, cancels out on the right side. And what we have now is a little bit of long division. 4 going into 180. 4 goes into 18 4 times. Minus 16. Drop that 0. And now we have 4 going into 20. 4 goes into 20 5 times. And that's a clean division, no remainder. That is 45. So our ending rate is going to be 45 miles per hour, everybody. And there we go. That's why the correct answer here is answer choice B, 45 miles per hour. All right, here's another one. Let's keep it going. What's the question? So the question reads, how many boxes can fit? Okay, so how many boxes can we fit? That's what we're trying to figure out here. So with that, let's take a look at the information that's given. Again, let's just move forward here. Let's see what we want. Because when we see the phrase or question, how many boxes can we fit? That may not explicitly state that we're dealing with geometry. So again, just take it one step at a time. So let's figure out how many boxes can fit by first understanding that we're dealing with a rectangular garden and it measures 15 meters by 10 meters. So we have a rectangular garden and it's 15 meters by 10 meters. Okay, nice and easy. And we see that each planter box needs 3 square meters of space. So if I want to go ahead and illustrate this, let me show you what this kind of looks like. First, let me grab what exists. Let's make it a little bigger. And everybody, here's what's going on. This is our garden. All of this area here is a garden. And we can say that, hey, this planter box, This takes 3 square meters of space. We got 3 square meters of space over here, 3 square meters of space over here. Everybody, what's the key word in this red highlighted text over there? What's the key word that I really want to underline to give myself an idea of what operation we need to do? Again, right here, which of these words in the red highlight specifically should I circle? Yeah, the word fit. Remember, everybody, when we're asking ourselves how many of one value can fit into another value, what operation are we thinking of? Yeah, we're thinking of division. That's right. Whenever we ask, hey, how many times can this fit into this bigger number, this bigger value? That is going to be division every single time. So, what is it that we're doing here? We are going to take the area of the garden and we are going to divide it by the area of the planter box. That's what we're trying to do. Because if we are able to divide the entire area by the area of each planter box, we're going to figure out how many planter boxes we can fit in the entire garden. My party people, before I get to the actual calculation, does the premise of the problem make sense? Because we're trying to see how many of one value fits into another value. This is division. There we go, everybody. Again, one day better, one day at a time, one problem at a time. So let me go ahead and take what we have and make it just a little smaller. And let's find the area of the garden first. So area of the garden, everybody, what's that going to be? Well, the area of a rectangle is the length times the width. So now we just have to plug in the values we have, which is 15 meters times 10 meters. And that's going to be 150 square meters. So we have the area of the garden. Perfect, right there. Now, everybody, what's the area of the planter box? What shape is the planter box? That's a little bit weird, right? They didn't give me a shape. Did they give me the area specifically? Did they give me the area specifically? That's right, Giovanni. Before anybody even said anything, yes, they did. Right here, because they gave us that the box needs 3 square meters of space. That's the big indicator. Remember, we talked about this plenty yesterday and today. Area is square units. So the planter box measurement that they gave us already, it's already in area form, square meters. So with that, we're good to go. 150 square meters divided by 3 square meters, that's going to end up being 50. 50 boxes can fit. And there we are. Snap, crackle, pop, we're good. Answer choice is D. My party people, how are we feeling? Are we feeling good about, being challenged mentally to look at these problems in all these different ways? Again, it's not just about knowing your formulas. It's about knowing how to adapt with the formulas when you're introduced to these new circumstances. All right, so with that, let's go ahead and get over to the next one as always.